There are two ways to build your models in the top-down method. You can create a new part in this assembly, or you can insert components and start editing within the assembly from there. I'd suggest inserting components because I just found it easier for naming. So you want to build your models using a guide sketch. Guide sketches are simply a skeleton of your models that kind of contain your driving features, and it requires a little bit of forethought, but you can it'll help you be more flexible in the future. So let's go ahead and save this with the proper naming convention. And let's go ahead and make one more part because we're going to be using it in the future. And hopefully we can show you the importance of the guide sketches. If you ever need to change the plane you're drawing in with a 3D sketch, press Tab. Make sure to close these guys so we can edit them. And we'll go back to our assembly and insert our components. So it's fixed right now because it's the first part I put in. So let's go ahead and make it float. So now I should be able to do that. And you take your model guide sketches and made it to the master assembly guide sketches. And hopefully you can kind of start seeing how laying these lines out allow you to change certain features on the fly when you need to. And I just dimensioned it to these three planes over here, which are our datums on the car this year. So now that we completed inserting it, let's start editing the guide sketch so that it's useful for us. So first, let's introduce what is called a global variable. Let's go to Tools, Equations, and these global variables are values that you can use and pass in between each subassembly. Now, it's the best way I found to relate these critical dimensions to each other. And I found that guide sketches were better for spacing, locally finding where the subassembly should be. So let's call this bearing diameter and give it a value of 3.5. Now I did it in the top-down assembly because you want to be able to reference it to all the other files that you have. So let's go ahead and save this, but instead we'll give it a global variable, which you can find right here. And in order to locate where I want it, oops, not angly, but over here, say it's 5.5. So now is when you'd start building your sketch inside. So we'd build it in the front plane of our sketch. And I made it a little bit smaller because I want to reference our guide sketch by saying that they're equal. And so whenever you change the guide sketches, it should change your driving features. And so let's go ahead and make an OD, and I'm making, let's just say, a motor mount right now that's above the Drexler. Alright, and let's trim here. And now we can extrude. Alright. And so we got our first part made. Let's go ahead and insert our second component and make the guide sketch here to here. And the plane, we'll go find its plane and made it to center line. Oops. Voila. And so now I want to edit that new guide sketch and make it a global variable. Oops. Cool. So now I'm going to sketch again. Not the 3D sketch, but and we're gonna want to make this guy the same diameter as the guide sketch. And for displaying purposes, we'll make it a little bit longer so you can easily see it. Save the part. So now, let's say we found out that we can make the bearing a smaller diameter and keep their stiffness up and lower our weight. So you go over to our global equation here. We can change it to 2.5. So as you can see, it changed the part. And it changed both references, which is sweet because I found that global variables are the easiest way to pass these critical dimensions to each other. And then let's say that we found out that we could also lower it. So we wanted to lower the CG. Go ahead and edit this, and we located our part using a guide sketch here. Let's lower it down. And it affects both models, which is great. Now, let's say like an even bigger decision causes us that we need to change something, such as wheelbase. Instead of blowing up, because the nature of which they're all referenced, the changes all trickle down.